Hello students, in this video we are going to discuss about the simulation of the switch reluctance motor using ANSYS Maxwell software. Actually this video is divided into two parts. Part 1 consists of the design of the switch reluctance motor by using the ANSYS Maxwell RMxprt tool, and the second part it consists of result of the discussion about the result of simulation by using ANSYS Maxwell RMxprt. Actually, why we are going through this video? Because till now we had continue the lecture series on power system analysis, and we are having the idea that in case of the power system analysis, mostly we prefer the different softwares to reduce the calculation time as well as to simplify the procedure for the power system analysis. We are having the idea that we are using the different softwares for the power system analysis purpose, like MATLAB software, then ANSYS Maxwell, then ETAP software, etc. Till now we had discussed about the use of MATLAB software, in which case we had discussed about the calculations or simplification of calculation in per unit system by using the MATLAB software. Then we had discussed how to draw the equal area criteria by using the MATLAB software. In today's lecture, our main aim is that focus the use of MATLAB software for the power system analysis. And in this case, we are going to study the simulation, that is design and simulation of SRM switch reluctance motor using ANSYS Maxwell software. So first of all, before going to start the simulation, you should have idea about two things. First one, switch about the switch reluctance motor, and second one about the ANSYS Maxwell software. So in case of the what is meant by the switch reluctance motor, as the name suggests, switch, that means in this case by using the switching technology we are going to excite the stator windings of the switch reluctance motor, and according to the reluctance principle, rotor try to occupy the new position. Thus the principle of rotating the electric motor is depend on the reluctance, and that's why this motor is called as the switch reluctance motor. But what are the advantages as compared to the conventional motor in this case, or why the switch reluctance motor is having advantages? Because in this case the main point is that the use of the rare earth magnet is very less, because in this case rotor is not having any winding. The winding is provided on the stator only, and rotor changes to the new position by using the reluctance principle. Thus the use of the rare earth magnet is less, and hence mostly switch reluctance motor are in demand for the recent application, because we know that right now the switch reluctance motor the availability of the rare earth magnet is very less, and we are importing the rare earth magnet from the China, and hence there is a need to develop the option in which the use of earth magnet should be less. Now we are going to design this motor by using the ANSYS Maxwell software. So of course ANSYS Maxwell software is having different application through which we can make the 2D 3D design, then but mostly its main application is related to the API analysis or thermal analysis of electrical equipment in which magnet is in use, or it is basically mostly related to the study of equipment or study of their magnetic theory. So we are having the idea that in case of the motor also we are using the magnet, and hence the main purpose of the today's lecture is design and simulation of the switch reluctance motor using ANSYS Maxwell software. Of course, we will go through the step-by-step procedure for design, and then we'll discuss about the analysis result. Okay, so in case of the switch reluctance motor, there are different types, like according to the number of stator poles and number of rotor poles, like 12 by 8, 8 by 6, then 6 by 4, etc. In this video lecture, we are going to design the 8 by 6 switch reluctance motor. So what is mean by the 8 by 6? 8 by 6 is nothing but 8 is number of stator poles and 6 is number of rotor poles. Okay, so directly I will go to the software. Then you will open the software. This is the window for after opening the software. Here is the project manager. Then you have to open the project. Suppose you have to open the project. What are the options right now given? File, then edit, view, project, tools, windows, and help. Okay, so suppose I have to open the project, then just I have to go to the file, then open, and I will try to open a already given. Suppose I will open this project SRM1, then it will take some time to open the project. So this is the over. So what is mean by the 8 by 6 switch reluctance motor? 8 by 6, that means these are the stator number of poles are 8 and rotor number of poles are 6. That's why it is called as 8 by 6 switch reluctance motor. Now actually if you go through the content, what are the input parameter required? See, in case of this RMxprt design, first one is the machine, then you have to design the circuit for the supply, then in case of the stator you have to give the some parameters, then winding details you need to provide, then you need to provide the rotor details, then whether you have to check or uncheck the shaft, and then you have to do the analysis. In case of the machine, there are different input required, like machine type, then what is the frictional loss, what is the windage loss, what is the reference speed of the motor, then control type. In case of the control type, there are different technique, like uh, chopped current control method, then direct current control method, that is the DC and triple C, then circuit type. In case of the circuit type, you can select the different option, that is voltage or half voltage or coupled coil, etc. So you have to give the input accordingly. Now in case of the circuit, that is the which is the supply part for the motor, you can select the lead angle of trigger in degree. That is, in case of the controller or converter technique, you can select the lead angle of the trigger, then trigger pulse in degree, then transistor drop of one transistor in hold, then what is the diode drop, because in case of the controller circuit, that is converter and control circuit, we use the different diode. So what is the diode drop, then what is the maximum current, then minimum current, that you need to discuss. Then you have to give the details of the rotors, that is what is the outer diameter, inner diameter, length, steel type. That is, here you are having the option to select the material, because through you can do the selection of the material, and their properties are given, like see, there are different material like alnico, aluminium, beryllium, brass, bronze, then steel, molybdenum, nickel, etc. And they are given with their properties also. You can select the any material, and accordingly you can do the analysis, and after the analysis you can select the optimize or the better material which fulfill your requirement of design. Then stacking factor, you have to provide the stacking factor, the number of poles of the rotor, endurance value, then yoke thickness. This value you need to provide as a input. Then shaft, whether you can check or uncheck the shaft. For this design, there's checking of the shaft, that is shaft is available. Okay, and then you need to do the analysis. Now what we'll do, we'll start from the start point, and we try to design the switch reluctance motor. Okay, so for that, see, there are different options like file, edit, view, project, machine. In case of the RM expert, there are machine type, list, validation check, then for the analysis of the design, then the design settings, then analysis setup, optometrics analysis, results, design properties, design data sets. You are having the idea that whenever you are going to use any software, the practice is only one option through which you can make the command on that software. So of course, whenever you practice more, at that time you will get the more idea about this tool. But right now, just I am giving the overall introduction. Then in case of the tool, see, there are edit libraries, library tools, project tools, run script, then calibration wizard, layout links. These are the different options are available. Then in case of the windows, new window, cascade, tile horizontally, tile vertically, arrange icons, then close all. Then in case of the help, here the manuals are also available. See, Maxwell PDF, then ANSYS corporate website, ANSYS, about the ANSYS electronic desktop. You will get the idea. That is theoretical information about the software through the help menu. Then there are different symbols. See, this is the symbol for the new file, then to open file, then save project, then uh, next I will reduce the size of this actually to get. I try to zoom in. Okay, now it is visible. Then this is the option for the actually this green indication, it is related to the validate. That means when you will do the design and do the analysis, before going during the analysis, if there are any errors in the design, then it will be displayed. Then add a solution setup, then analyze the all option, edit notes, then you can provide the solution data, then zoom out, zoom in, and fit all. These are the different options are available. So now we are having the idea regarding the window for the RM expert. So now we'll try to design one switch reluctance motor. See, here are also different options. What is the first option? Insert HFSS design, insert HFSS 3D layout design, then insert HFSS IE design, then insert Q3D extracted design, then insert 2D extracted design, insert circuit design, then insert circuit netlist design, then insert Maxwell 3D design, insert Maxwell 2D design, then insert RMxprt design. So actually in this video lecture we are going to design by using this RMxprt tool. Then apart from that, insert Maxwell circuit design, insert simpler design, then launch EMIT, insert filter design item, etc. So what we have to do, we have to design the switch reluctance motor by using the ANSYS Maxwell RMxprt tool. So I will go to the insert RMxprt design. So there are different options. See, through the RMxprt tool, which type of the motors you can design and simulate. First one, adjust speed synchronous machine, then brushless permanent magnet DC motor, then clock pole alternator, DC machine, generic rotating machine, land start, permanent magnet synchronous motor, permanent magnet DC motor, single phase induction motor, switch reluctance motor, three phase induction motor, three phase non-silent synchronous machine, three phase synchronous machine, universal motor. So these are the different type of the motor which you can simulate by using the RM expert tool in ANSYS Maxwell software. Okay, so right now we have to design the switch reluctance motor. So I'm going to select the switch reluctance motor and I will press the OK. So this is the now this is the design tool which is for switch reluctance motor. Okay, that is RMxprt design for switch reluctance motor, and I have to design the motor. So as we had already discussed, these are the parameters which I need to give as an input. So in case of the RMxprt design switch reluctance motor, when I press on this plus option, then it will show the additional subtype in that main part. So in case of the machine, actually what are the parts which we have to design? Circuit, then in case of the stator, then stator winding, rotor winding is not available in case of the rotor, in case of the switch reluctance motor, then shaft. So I will start with the first part, that is machine. See, in case of the machine type is switch reluctance motor, which we had already selected. That is switch reluctance motor we are going to design. Then frictional loss, that is you have to give the as an input. What is your range of frictional loss in case of the your design? So just I will give the input data. Actually already I have simulated this, and I will try to give the input so that you will get the idea how to give the input in case of the design. So here we are actually going to design the 550 watt 48 volt switch reluctance motor. I repeat, here we are going to design 550 watt 48 volt switch reluctance motor, and the another specification is it is 8 by 6 machine. That means 8 is the stator number of poles and 6 is rotor number of poles. So frictional loss for our selected design is 8 watt. So you can give the input as per your requirement. So I am giving the frictional loss is in 8 watt. Okay, then windage loss. See, we are having the idea that in case of the switch reluctance motor, there are different type of the losses like frictional loss, windage loss, and that you need to provide as an input. So in case of the windage loss, we'll select the it is 4 watt. See, this first parameter gives the details of the parameter. Then this here you have to select the magnitude or value of that parameter, and these are the units. You can, in some cases you can change the unit also. See, in case of the frictional loss, there are the different options, like you can provide the input in different parameters. Here we had selected the watt, and once we give the input, that evaluated value is given here. Okay, and for if you are not having the idea what is the meaning of this parameter, you can go through the description where you will get the more idea. Like suppose frictional loss, then it will indicate the details of it. So through that you will get the more idea about the that input. Now reference speed. See, the reference speed, here you can select the reference speed. So what is the reference speed? The reference speed at which the frictional and windage losses are measured. So I will select the reference speed for this my selected design as 3500 rpm. So I will give the input 3500 rpm. It will be, apart from that, you can provide the speed as an input in different parameters. You are having the different options, but we had selected the rpm, revolution per minute. Then control type. In case of the control type, there are two types: direct control and chopped current control, that is the DC and triple C. Right now I'm going to select the option of DC control type, direct current control type, because I'm going to select the 48 volt DC as an input voltage for the selected motor. Okay, then in case of the circuit type, see, in case of the circuit type, actually there are different options. So what are that different options? So I will double click here. So these are the full voltage, then half voltage, then coupled coil, etc. So for the full voltage, the diagram is shown. Similarly, for the half voltage, diagram is available. For coupled coil, diagram is available. You can select the any one input. So here I will select the full voltage option, and I will press the OK. So full voltage is selected. So we have given the input as an parameter for the machine, and I will press the apply button so that these designs will be applied to the our selected design. So machine input we had given. Now we have to design. Now we have to design the circuit of this switch reluctance motor. So in case of the circuit, see what are the different option. You have to select the lead angle of trigger in electrical degree. So actually this is related to the part of controller. See, in case of the switch reluctance motor, in case of the supply part, it is divided into two parts. First one is the converter to provide the DC voltage as per the requirement, and second one is the controller, which will control the speed of the motor or performance of the motor, and for that purpose we use the position sensor, which will give an as an input data to the converter and controller. So here, in case of the in that case, it is consist of different diodes, then transistors, etc. So here, lead angle of the trigger. So what is the lead angle of the trigger for our selected design? Lead angle of the trigger in electrical degree, we will consider it 0. Of course, there are different options for input, and you can select give as an input of lead angle of trigger. Here I will select it as 0. Then trigger pulse. So in case of the trigger pulse, what is the unit? Degree. So trigger pulse, I will select the trigger pulse in electrical degree equal to the 120 degree. Okay. Then transistor drop. Okay. As we had already discussed, there are different type of the transistors are also used for switching purpose, and that transistor drop you have to give as an input data. So voltage drop of the one transistor. The meaning of this transistor drop is voltage drop of one transistor. So we will consider the voltage transistor drop is equal to the 0.5 volt for selected design. Of course, you can give the input as per your design, but just I am giving the idea how to provide the input data. Then diode drop. So here diode drop is nothing but voltage drop of one diode or the total voltage for star type circuit in the discharge loop. Okay, so here we will select the diode drop as 0.5 volt. So I will select 0.5 volt. Okay, so we had given the input for the circuit data. Then similar to the last case, we'll apply this design and then we'll press the OK. So we had designed the machine, or we had provided the input data for the machine design, we had provided the input data for the circuit design. Now we'll design the main parts of the switch reluctance motor, which are nothing but stator and rotor. So for the stator, I will just double click on the stator. There are the different parameters in case of the switch reluctance motor, and we had already discussed in case of the switch reluctance motor, stator is having only winding, and then supply is given to the stator winding. For example, and a number of phases of the motor also depend on the number of stator poles. Okay, suppose there are total 12 number of poles are available. That means the on each pole there will be the winding, but two poles apart from that, two opposite poles will form the one winding. I repeat, two opposite stator poles of the switch reluctance motor forms the one winding. For example, if there are total 12 number of poles, then two opposite pole form the one winding or one phase, and thus there will be total number of phases will be 6 in case of the 12 by 8 switch reluctance motor machine. Then similarly for 8 by 6 pole, 8 by 6 switch reluctance motor, 8 is the total number of stator poles. Two opposite winding or opposite pole forms the one phase, and hence it will be 4 phase motor. And similarly for the 6 by 4 switch reluctance motor, 6 is the total number of stator poles, and two opposite poles form the one phase, and hence it is 3 phase switch reluctance motor. So for this motor, we are consider the we are going to design the 8 by 6 switch reluctance motor. That means total number of stator poles are 8, and hence it is 4 phase switch reluctance machine. So in case of the stator, we have to give the input data of outer diameter. So here we have to give the outer diameter of the stator core. What are the units? These are the different units, but we are going to provide the unit input data in mm. So we'll provide the output diameter of the stator in mm. So for selected design, we'll select the outer diameter of the stator is 120 mm. So I will provide the 120. So 120 mm is the input data. Then inner diameter. We know that in case of the stator, its stator core, it is having some breadth, and outer diameter and inner diameter, these are the input parameters related to the stator design. So output diameter we had selected 120 mm, and regarding the input diameter, here we will select the input diameter of the stator as 75 mm. Similarly, here different units are available. We had selected this inner diameter in mm, and which is equal to 75 mm, which is also shown in evaluated value. Then length of the stator. Actually, this is the length of the stator core. Okay, so we need to select the length of the stator core. There are different options are available regarding the unit. We select the mm as an input data. So for this design, we will select the length of the stator core equal to the 65 mm. Okay, length of the stator core is 65 mm. Then stacking factor of the stator core. So we had selected the stacking factor of the stator core is 0.95. Of course, it is less than 1. We had selected the 0.95 for our design. Then steel type. See, we know that the performance of the machine also depend on the material which is used for the stator core, which is used for the rotor core, then which is used for the binding on the machine. So in this case, for the stator core, you are having the option to select the different material. That is the main advantages of doing the analysis, because if practically we are going to check the performance of the machine by using the different material, then it will be waste of the time as well as it will be the waste of the money. So here in case of the steel type, material is not assigned. So when I will double click, I am having the different options of material for the stator core. See, these material details are given. So this is the name of the material, then location, origin, type, relative permeability, that is BH curve of the material, then bulk conductivity, then what is the core loss, what is the thermal conductivity of that material, what is the mass conductivity of that material, then what is the specific heat. So these are the different information, that is the detailed information of that material is available. So you can go through that information and you can select the material as per the your requirement. So what are the options for the material? You can select the alnico, then alnico 9, then aluminum number 2 EC, beryllium, brass, bronze, cast iron, ceramic 5, ceramic 8D, then chromium, cobalt, ferrite, indium, iron, M1924G, M1924G, 2DS F0.950, then magnesium, molybdenum, then immu metal, then NDAP 30 nickel, then palladium, fake, then platinum. These are the different materials. Then solder alloy, solder casting. So then steel 1000, in case of the steel there are different type like steel 1008, steel 1010, then steel stainless, then tantalum, tin, titanium, tungsten, zinc, zirconium. So these are the different options through which we can select the material. But for our design, suppose we will select the steel 1010 material. Now what are the properties of this material? Whose bulk conductivity is 20 lakh Siemens per meter, then magnetic coercivity is 0, core loss is not available, thermal conductivity is 45, then mass density is 7872, specific heat is 448. So these are the details of this selected material. Thus we will select the steel type material. Of course, whenever you do the design and analysis, and if you want to change the material, you can change the motor, you can analyze the performance, and you can select the material the which will best suit for your requirement in the design. Then number of poles, as we had already discussed, that there are different configuration in case of the switch reluctance motor, like 12 by 8, 8 by 6, 6 by 4, etc. Here we are going to design the 12 by 8 by 6 machine, that is number of stator poles are 8. So I will select the number of stator poles are 8. Then MRAS value, we had selected the 0.5, okay, which will give the pole MRAS. Then yoke thickness, in case of the yoke thickness also we are having the different options as an input data, but will provide the input data in millimeter only. So I will select the option, and it is nothing but the yoke thickness of the stator core. So I will select the yoke thickness of the stator core as 9 mm. 9 mm. So thus we had given the input data for the stator like output diameter, inner diameter, length, stacking factor, steel type, number of poles, embrace, yoke thickness, etc. Then I will press the apply button, so that according to that the machines will be designed. So see, when I had given the stator input data, the geometry of the stator is available in the window. So this is the 8 pole stator of the switch reluctance motor which we are going to design. Okay, but if you give the some irrelevant values, then it will show the error in the progress bar or command window of this software. Okay, now what is the next part for the design? We had given the input for the machine, we had given the input for the circuit, we had given the input for the stator. Now we have to design the stator by, see, in case of the switch reluctance motor, winding is available on the stator only, so we need to provide that input on the stator only. In case of the rotor, this winding will not be present. So in case of the uh, winding design, first part is insulation thickness. So what is the meaning of the thickness of the insulation between stator core and field winding? I repeat, thickness of the insulation between stator core and field winding. See, if you go through this table, it is similar to the stator input data. That is name of the parameter, but the value we need to provide as an input. Then unit, that is you are having the different options for unit of that parameter. Then estimated value, it will selected once we provide the input data. And description, if you are having if you are interested in the more information about the selected parameter, you can go through the description. So like insulation thickness is nothing but thickness of the insulation between stator core and field winding, and you are having the different options as an input parameter, but we'll provide the input in mm only. And for the selected design, the insulation thickness of the binding is 0.3 mm. So I will select provide as an input 0.3 mm. Okay, now end adjustment. So what is the meaning of end adjustment? The one side end extended length. So here end length adjustment is 0 mm, which is already selected. Then parallel branches. In case of the winding, if there are parallel branches are present, you are already having what are the advantages of the parallel branches. So it will help to distribute the current, and hence the size of the wire or winding required is less. So parallel branches, and what is the meaning of this? Number of parallel branches of the stator winding. So number of parallel branches are 1, that is we'll select the only one parallel branch. Then turns per pole, what is the meaning of it? Number of turns per pole, 0 for auto design. Suppose we keep it as 0, that means it will select the turns per pole automatically. Okay, but if we have to give the input, if you are having the some input data as per your theoretical calculation or as per your experience, then you can give the input data as a number of turns pole directly. So here I will give the number of turns pole per pole 20. Okay, now number of strands. So what is the meaning of this? Number of strands, that is number of wires per conductor, and 0 for auto design. We are having the idea that in case of the stranded wire, in one conductor there are large number of the small wires are available. So that number of strands or number of wires which are available in one conductor, that input we can provide. So for this case, we'll consider the number of wires per conductor is equal to 1 only. That means your winding is having only single conductor. It is not a stranded wire which consists of the large number of conductors. Okay. Then wire wrap. What is the meaning of this? Double side wire wrap thickness. Here also 0 for auto pickup in the wire library. That is, if you select the value 0, you are not having the much more information. Then also you are having the flexibility in the selection of the design. So that value will be automatically pick up from the wire library if you select the 0 value. But if you want to provide the input, you are free to provide the input. So here number of wire wrap thickness, I will select it is 0.08 mm. Of course, for the input there are the different options, but we'll select the mm. Now wire size, which is the main important parameter in case of any winding. So here you have to need to select the wire size. Of course, the wire size will be depend on the current carrying capacity, and of course it will depend on the uh, size of your motor. Of course, whenever the power rating is more and voltage level is less, at that time the current carrying capacity of the conductor should be more. When the power is less, voltage is more, then current carrying capacity of the conductor required is less, and you can select that wire according to the requirement of your design. See, in case of the wire size, they had given that 0 for auto design. That means if you are not having the pre-calculated parameter, if you just want to check the performance of the motor for different parameter, then you can select the 0 and it will automatically designed value will be selected by the software for your design. Okay, but if you are having the value, you are having that much expertise, then you can select the wire size. Wire size, see, unit systems are available, that is mm. Then wire diameter, you are having the different options for the wire diameter. Right now it is 0 for auto design, and gauge of the wire is also given, like mix 4 by 0, 3 by 0, 2 by 0, 1 by 0, 1 by 0.5 and 1. These are the different gauge of the wire. So here the gauge number and diameter of the wire is given. You can select any type, like which are the option, like for 4 gauge the wire diameter is 11.684. Of course this value is in mm. Then for 3 by 0 gauge number, it is 10.40 mm. For 2 by 0 gauge, it is 9.266 mm. For 1 by 0 gauge, it is 8.252 mm. For 1 by 0.5 gauge, it is 7.788 mm. For 1 gauge, it is 7.348 mm, and for 1.5 gauge, it is 6.934 mm. Okay, so apart from that, you are having another option like 1 for gauge 1, 1.5, 2, 2.5, 3, 3.5, and accordingly your diameter values also changes. See, you are having the options for the gauge up to the 52 from the 4 by 0. For the diameter, you are having the options from 0 point minimum value is 0.0198 mm to 11.684 mm, because we are having the idea that lower the value of gauge, higher is the diameter. Okay, so for this design or our design, we'll select the wire gauge. Wire diameter is 1.628. So we see here at the 1.628 mm diameter. Yes, it is for 14 gauge. So that means we had selected the 14 gauge and 1.628 mm diameter. This is the selection of the conductor for the winding. Thus we had given as an input data for the winding, which is insulation thickness, end adjustment, parallel branches, turns per pole, number of strands, wire wrap, and wire size. So I will apply this input. So till now we had given an input for the machine design, for the circuit design, for the stator design, and winding design. Now we have to select the another parameter, which is nothing but rotor. Now since our 8 by we are going to design the 8 by 6 machine, that means of course there are number of rotor poles are nothing but 6. Okay, and for the rotor design there are different parameters like name, value, unit, evaluated value, description, etc. So in case of the name, there are different parameters like outer diameter, inner diameter, length, steel type, stacking factor, number of pores, M branch, and yoke thickness for the rotor. Then value, where you can provide as an input data. Then in case of the unit, you are having the different options to select the input of given parameter, unit of the given parameter, then evaluated value will be shown here. And if you are not having the idea, or if you are interested in the more information about the selected parameter, you can go through the description. Okay, so we'll start with the first point. This is the rotor, outer diameter of the rotor. See here, outer diameter of the rotor is nothing but in nearly equal to the input diameter of the stator. So what is the input diameter of the sorry, inner diameter of the stator? It is, I think, 75 mm. Okay, so I will select the outer diameter of the rotor nearly equal, that is suppose 74 mm. And here are the different options for the given input data, and see evaluated value is showing here. And choose the outer diameter of the rotor core. Now next parameter is inner diameter. That is, what is the meaning of this? This in description, it is inner diameter of the rotor core. Now in case of the inner diameter of the rotor core, also you are having the different options for the unit, like centimeter, then in meter, kilometer, etc. And another options are available. I will select the data. And what is the inner diameter for the our selected rotor? It is 30 mm. So I will select the input diameter is 30 mm. Okay, input diameter of the rotor is 30 mm. Then length of the rotor. So in case of the length of the rotor, also you are having the different option. What is the meaning of this? Length of the rotor core. Okay, here you need to select the length of the rotor core. So for this design, actually length of the rotor core is 65 mm. Here also you are having the different option, and selected value is shown as a evaluated value. Now steel type. As we had selected the material for the stator core, we had selected the material for the stator winding. Similarly, you can select the material for the rotor. Uh, so you are having the different options again here, and the material properties are also given similar to the stator option, that is name, location, origin, type, relative permeability, then bulk conductivity, magnetic coercivity, core loss, thermal conductivity, mass density, and specific heat. That means these options or properties of the material are similar to the options which are available in the selection of the material for the stator. So, and what are the different options? Again, here are different materials are available, like alnico, aluminium, brass, bronze, cast iron, then ferrite, then iron, M1924G, magnesium, then nickel, platinum, solder, then steel, in steel 1008, 1010, then steel stainless, then zinc, etc. Different options are available. But for our rotor design, we will select the material which is steel 1010. So I will select this material. And what are the properties of this material? This is having 20 lakh Siemens bulk per meter bulk conductivity. Then core loss is, magnetic core loss is almost 0. Then thermal conductivity is 45, mass density is 7872, and specific heat 448. So these are the specifications of the material steel 1010, which is selected for the rotor core. Then stacking factor. Stacking factor is 0.95, which is selected according to the design. Then number of poles. We had already discussed we are going to design 8 by 6 pole machine, and that's why the number of rotor poles are nothing but 6. That is number of poles of the rotor core. Then impedance value is 0.5, is already selected, and yoke thickness. Now you are having the different options as an input for the yoke thickness in mm or meter, centimeter, etc. And it will give the idea about the yoke thickness of the rotor core. So for this, our design will select the yoke thickness equal to the 9 mm. So now you are having the we had provided the input parameters like outer diameter, inner diameter, length, steel type, stacking factor, number of poles, time branch, and yoke thickness of the rotor. And just I will apply it as an input. So the geometry of the rotor is now available. See, this is the geometry of the rotor. That is total 6 number of poles are available. If you select the 4 pole rotor accordingly, or if you select the 8 pole rotor accordingly, geometry will change. But if you given any random value which is not an correct parameter as an input data, then it will show the error. So if we double click or select the machine, then it will now show the configuration of both stator and rotor, that is of the entire machine. That is total 8 number of poles are present, total 6 number of poles are present, and this is the point. This is the location for the shaft of the motor. Okay. Now for the shaft, your next parameter is design of the shaft. In case of the design of the shaft, you have to just check or uncheck the magnetic shaft. Here we had just check the magnetic shaft and we will press the OK. So now your input parameters which are required for the design of the switch reluctance motor are given. That is the you had given the data of the input for the what is the voltage rating, what is the speed, then circuit type, stator, binding, rotor, shaft, etc. Okay. Now you have to do the analysis, but before the analysis you have to confirm your design whether it is correct or not. For that, actually what you have to do, you can select, right click on the analysis and do the add solution setup. So in case of the add solution setup, it is divided into and here we have to uh, we are going to do the input of the type. So here there are, in case of the, what are the different options are available for the solution setup. Operation type, of course it is motor, that's why it is automatically selected motor. Then in case of the load type, you are having the different options like constant power, constant speed, constant torque, linear torque, fan load, etc. according to the for which application you are going to use the design motor or the motor which is under design. So here we will select the constant power application. Now rated output of the motor. Now output of the motor is, you are having the option in different from nanowatt to HP. Okay, so here we will provide the input rated output power of the motor as per the watt data. So it is 550. In this case, they are the small size of the motor, that is 550 watt. So 550 watt, and what is the rated voltage? We'll select this voltage as 48 volt. Of course this voltage is in DC, but you are having the option for the voltage also. You can provide the voltage from the voltage as an input to the motor in different units like millivolt, volt, kilovolt, megavolt, etc. Here we will select the voltage in unit, and the rated voltage is 48 volt. Now rated speed, here actually we will consider the selected motor which is of 3000 rpm. We had initially also selected this value, that is, sorry, 3500 ampere. So I will do the rated speed is 3500 rpm and operating temperature is 75 degrees Celsius. That is, we know that according to the temperature condition also the losses are different and hence motor performance get affected. Hence here in simulation there is option to select the temperature. So here I have selected the 75. That means the result of the analysis, it will give the performance of the motor at 75 degrees Celsius. Okay, and I will press the OK button. That means now I have given the all the inputs which is required for the motor. Now in case of the set a parameter, now I have to analyze that parameter. For that I will right click on the analysis button and I will press the option analyze all. So what is the meaning of the analyze all? Here actually the design input which are provided as an input will be checked by the motor, and if there is any problem or error in the design input, then it will be automatically shown. Thus we have provided this setup data, we had started the analysis. In case of the analysis, see here show progress parameter is given, through which you will get the idea about the analysis, whether it is completed or it is in input data. And there is one message is available, that is your design is okay. Okay, but if there is any problem, then on this message manager errors are given. That is, suppose your input is not fulfilling the requirement, or if there is any major mistake, then that warning will be given here in case of the message manager. So I will close that message manager. Now I had done the analysis, but here the validate checkup result is present, and here tick mark or green color indication shows that your design is validated or it is valid design. So if we go through this window, design settings are shown by green color. That means design settings are validated and it is up to the mark, or those are correct values. Then machine design are validated, then analysis setup validated, and optometrics is also validated. So I will press the so I will provide the now validation is completed. Now I have to go through the result sheet. Okay, so for the result sheet, what you have to do, just right click on the setup. There are different options. See, copy. If you want to rename the project, you can rename, you can delete the project. Then properties, then disable setup, analyze, submitted job, then check quick report, performance, design, curve, expert, then create Maxwell design. That is, you can convert this RMxprt design into the Maxwell 2D and Maxwell 3D directly. So actually we have to check the design sheet, then design sheet will be automatically available. Of course, what are the different parameters that we'll see in the next part of the video lecture. But you will get the design sheet. You can check the performance. You can, even the different curves will be available. Then in case of the properties, these are the properties of the machine. Actually this point is get deleted by mistake, so just I will give the input again. That is, rated output power is 550 watt, rated voltage is 48 volt, which we had already given. already discussed. Speed is 3500 rpm and temperature is 75 degrees Celsius. Okay, and just I will analyze this data. Sorry. And this the progress of the analysis will be shown here. Then through the validation check, I will check the design validation. Yes, it is validated, and I will try to find out the output data. So in case of the properties we had, then this you can disable the setup, analyze, then submit the job, then create quick report. In this case, if you get idea about the current, flux, inductance, power, torque, voltage, etc. That is, if I select the voltage, then I will get the idea about the voltage parameters only directly here. Okay, and this graph can be exported or imported, and you can check the properties also. Then you can modify the report, you can save the report templates. Okay, so this will shows the results. Then performance of the machine is also shown here. That is, the different point are given, that is the motor performance, API input data, then motor performance under full load operation, motor performance under material consumption, then no load operation of the motor, start operation of the motor, stator winding performance of the motor. That is, you can check the performance of all these parts of the motor or overall performance of the motor. So thus in this video we have discussed how to design the motor as an input data and how to do the uh, analysis, then how to validate your design data, and how to reach up to the solution setup. Okay, in next video actually we'll discuss which are the output parameter. That is, till now we have discussed the input parameter which is required for the design, but in next lecture we'll discuss about the outputs which we will get the from this simulation, and we'll do one by one discussion about each parameter. But right now just keep in mind that through the RMxprt it is possible to design the different motor. We had seen the example of the 8x6 switch related motor. Then another advantage is that you can convert this design into the 2D design directly. You can convert this RMxprt design into the 3D design of the motor directly, and you can do the corresponding analysis. And regarding the motor performance, if you get the result sheet, if you go through the result sheet, then you can check the performance of the motor. And if you want to change the material, or you want to check the performance of the motor by changing the material, you are free to check the material for the stator core, material for the winding, material for the rotor core, and you can check the performance, and from which you can select the better material for improved performance of the motor. But if the software is not available, what will be the problem? We have to use that material, you have to manufacture your motor hardware, you have to make your hardware model of the motor, then in laboratory you have to check the performance. But here within seconds you will get the corresponding graph of the performance of the motor, and hence it reduces the cost which is required to improve the performance. Then it reduces the time of the designer as well as the motor manufacturing company, as well as it reduces the cost, that is money which is required to make the hardware model. So these are the advantages. Thus power system analysis helps to check the performance of the machine before its experimental setup, or before it is going to use in actual practice. And that is the plus point why the power system analysis is, that is the main point why the power system is analysis is important in case of the power system. Okay, so we'll continue this video lecture in next session also, in which we'll discuss about the output data. that is what is the result sheet, what is the quick result, what are the different graphs, then which parameter you will get as an output data, then which parameters you can change to improve the performance of the motor. Okay, so just we'll conclude that in this lecture we had discussed about how to design the 8x6 switch reluctance motor. Then for this motor we had selected the RM expert tool, insert insert RMxprt design, in which we had selected the type of the motor, switch reluctance motor. Then we had given the input for the design as machine input, circuit input, stator, winding, rotor, shaft. Then we had analyzed and done the analysis, and we had validated the design with the help of the software. Okay, so we'll continue this lecture series, in which next part we'll discuss about the result or outputs which are obtained after the analysis. Okay, thank you.